Again, I'm Adebanjo Olaleko Peter, BSc Math OEG, MBBS in VIEW, LAUTECH. So, under derivation of equation using dimensional analysis, here we have another question that you can use or you can check together as an example. This question is talking about the velocity of a vibrating string. I have a vibrating string. The velocity of that vibrating string depends on the tension in the string and the mass per unit length of the string. So the velocity V of the vibrating string depends on the tension T in the string and the mass per unit length, represented by this symbol. If K is 1, want to use dimensional analysis to derive an equation that governs the variable. So we have that the velocity depends on the tension and the velocity depends on the mass per unit length, which implies the velocity depends on both tension and the mass per unit length. So changing this to equality sign, you introduce a constant. That is the first step. So when you introduce a constant, we have V is equal to KTX mass per unit length to power 1. So we check their dimension one after the other. So our velocity is in meter per second. So dimension is LC minus 1. Tension. Our tension is like a force, not like a force. The force in a string is called a tension. So now the unit of force is Newton, but the derived unit of force is kilogram meter per second square. So if you know that the unit of tension is kg ms minus 2, then dimension will be capital M L T minus 2. Then mass per unit length. When I say mass per unit length means mass on top, length below. That's kilogram per meter. So dimension is capital M L minus 1. We will now use this dimension to represent each of the physical quantities, which implies that for velocity we have LT minus 1 is equals to K into bracket. For tension, MLT minus 2 to power of X. For the mass per unit length, ML minus 1 to power of Y. Now from here, we of course, we have M, L, and T at the right hand side. We have only L and T at the left hand side. We can create L. So we have like M to power 0, L to power 1, T to power minus 1 equals to K into bracket. This one is M raised to power X dot L raised to power X dot T raised to power minus 2X. Close it into bracket. We can have M raised to power Y dot L raised to power minus Y. Now from here, we can have our M to power 0, L to power 1, T to power minus 1 equals to K into bracket. We have M and M here. M to power X dot M to power Y. Then we have L to power X dot L to power minus Y. Then we have T to power minus 2X. From here, we have our M to power 0, L to power 1, T to power minus 1 equals to K into law of indices. We have M raised to power X plus Y. And we have L raised to power X minus Y. Then T raised to power minus 2X. Carefully, we can easily equate these and these. L to L, then T to T. But if I should start with T, because I know on top of T here we have minus 2X. On top of T here we have minus 1. I can easily equate that one. So that we have T raised to power minus 1 is equal to T raised to power minus 2x, which implies that minus 2s is equal to minus 1. Then our s is 1 over 2. Is my s. Look at m. I can have m to power 0 is equal to m to power x plus y, which implies that s plus y is equal to 0. So s equals to minus y. But because we have our s as r, this is 1 over 2 is equal to minus y. So y equals to minus 1 over 2. Getting x and y, now our x is r and our y is minus r. Now if we where our k is 1, we'll come back to this. Let us call this equation beta. Equation beta. Now we replace s by r, y by minus r with r. Therefore, V equals to, that will be from beta, we have V is equals to 1 multiplied by, knowing our k is 1, T to power of r multiplied by mass per unit length to to power of minus r. So V equals to 1 times square root of T times 1 over square root of mass per unit length. So V equals root T over root mass per unit length. Both of them has a square root. I can take it as square root of T over mass per unit length. So V equals root T divided by mass per unit length. So velocity of a vibrating string depends on the tension T in the string and the mass per unit length. Mostly, if you want to use it to solve question, you'll be given the mass separately, you'll be given the length separately. You calculate mass over length for the denominator, and you'll be given the tension. The tension will be at the numerator, you divide it and you take square root to get the velocity of the vibrating string. Thank you.